Okay, so let's look at practice quiz 6, number 1. It says a mass weighing 40 pounds stretches a spring 1.5 feet. Determine the amplitude, period, and equation of motion if the mass is initially released from a point 0.75 feet above the equilibrium position with a downward velocity of 3 feet per second. Then we also have to graph one complete cycle of this. Okay, so in the last video we used Hooke's law to derive a differential equation which we solved, which gave us the motion of an oscillating spring. So let me write down the main information we derived last time. Okay, so here's the main information. This first guy is Hooke's law, and then our F is equal to mass times G, where G here is the gravity, and we have our W, or omega, is the square root of K over M, and here's our position function that models a oscillating spring. So it's x of t equals a sine of Wt plus b, where the a in front here would be the amplitude. Okay, so let's start finding all these things. So let's see what we're given here. Well, we're given up here the weight, which is going to be your F here, is 40 pounds. We're given the 1.5, that's going to be the stretch of the spring, which is going to be your S. The K is the spring constant, which we need to find. And we're also given that say it's initially at time 0, the position is 0.75 feet above the equilibrium, and it has a downward velocity of 3 feet per second. So let me write this information down here. Okay, so we're given is our F is 40, that's from up here. We're given our S is 1.5, that's from here. I'm leaving off the units. It's pounds here and feet here. I'm just leaving off the units. The G then would be 32, because that's the gravity in feet. So that'd be gravity is 32 feet per second squared. And then the position of the position at time 0, it says it's initially released from a point 0.75 feet above the equilibrium. And recall from last video, the way we're defining things here is where up's considered negative and down's considered positive. So release from a point above would be considered negative. So it'd be 0.75 would be negative 3/4 then. With a downward velocity, so again, down's considered positive, so it'd be 3 feet per second, so it'd be 3 here. Okay, so now let's use this information here to plug in up here to find our K, and then we'll try and find our W also. So let's plug the 40 in up here, the 1.5 here, and the G 32 here. So doing that, we get then. So doing that, then we'll have so in place of F, we'll have 40 Ks, so it'll be K times 1.5. We can then solve this for K, so dividing by 1.5 we get then. Okay, so solving for K, dividing by 1.5, K will be 40 over 1.5. Then when I get rid of the decimal down here, so multiply top and bottom by 10, so it'd be 400 over 15, which you can check reduces to 80 over 3. Then we'll also have this equation here, so we'll have 40 equals my M times 32, so 32M. Let's solve for M because I need to find my M up here. I need to use the M up here to find my W. So dividing by 32 then we get. So dividing by 32 we get our M equals 40 over 32, which reduces to 5 over 4. And actually, since we're in feet and pounds and stuff, the units on this would actually be slugs. So slugs. So if you're in engineering, you'll probably have seen this, I guess. Don't worry about the units here. Okay, so now we have enough information to find our W, because we found our K here is 80 over 3, and we found our m is 5 over 4. So let's find our w now. Okay, I'm out of space here, so let me erase a few things and we'll keep going. Okay, so I found our k was 80 over 3 and our m was 5 over 4. So our w then will be square root of k over m. So it'd be square root of 80 over 3 divided by this guy, same as multiplying by reciprocal. So 4 over 5 here. 5 goes into 80 16 times, you can check. And 60 times 4, 64. So it's going to reduce to 64 over 3 square root. And square root of 64 is 8. Square root of 3 would be square root of 3 here. So that's our that's our w value. Okay, so let's keep going. Okay, so now here's our equation of motion here. So our w we just found is 8 over square root of 3, so plug it in here. So we still have to find the a in front and the b inside here. Okay, let's work on finding the a next. So we're going to be using our two given conditions, that our x of 0 was negative 3/4 and our x prime of 0 was 3. So we're going to use those two conditions to find a. Okay, so let's keep going. Okay, so first we're going to use our condition that x of 0 is negative 3/4. So putting 0 in place of t up here, and negative 3/4 in place of x, which I've done here, negative 3/4 in place of x of t, be a sine 0 in place of t, which is going to become then a sine of b. Let's solve this for sine of b. So let's divide both sides by a. So doing that we get then. Okay, so dividing by a will solve for sine of b. So sine of b will be negative 3 over 4a. Next, let's use our other condition that x prime of 0 was 3. Okay, so doing that we get, okay, actually before using the x of 0 being 3, we need to find the derivative. So here's my position function up here. So I want to find the derivative, because the derivative of position will be velocity. So I'm going to find my x prime. So it's going to be derivative of sine, which is cosine, times the derivative, using chain rules, times the derivative of the inside function with respect to t would be 8 over square root of 3. So I come out on the outside here then. So this would be our derivative here using the chain rule. Now we'll use our condition that x prime of 0 equals 3. So using that up here we get then, okay, so I'm putting 3 in place of my x prime of t here. So 3, 0 in place of t. So I'd have then this. Let's solve this for cosine of b. So it's going to divide by this guy in front. So solving for cosine of b we get then, okay, so solving this for a then, so multiplying by, or dividing by this, ends up being this here. So cosine of b will be 3 square root of 3 over 8a. So now we have sine b up here and cosine of b here. So now we're going to use those. So now we're going to use the identity that sine squared plus cosine squared equals 1. Okay. Okay, so we using our sine squared plus cosine squared equals 1, our Pythagorean identity here. Now the sine is equal to negative 3 over 4a, so it will be negative 3 over 4a squared plus cosine, which we can use as 3 square root of 3 over 8a squared equals 1. So we have this guy here. Now I'm out of space here, so let me erase a few things and we'll keep going. Okay, so we have negative 3 over 4a squared plus 3 square root of 3 over 8a squared equals 1. So squaring this first guy will be 9 over 16a squared, which I have here. Squaring this, it'll be 3 squared 9 times 327 over 64a squared equals 1. Let's multiply both sides by 64a squared, because we want to solve for a. So multiplying by 64a squared on both sides, we get then, okay, so multiplying both sides by 64a squared. So 64a squared times the first guy here, 16 goes into 64 4 times, there'll be 4 times 9 left here, and 27 left here, and 64a squared left here. So solving for a, then we get, okay, so then we'll have our a squared equals 63 over 64. Taking square root, then a will be square root of 63 over 8. So let's plug this a back now in over here and here to find sine of b and cosine of b. So doing that, we get then, okay, so plugging in the gap we found for a here and here. So I've done it down here. So the reciprocal, because it's divided by a here. Simplified, the sine of b then become negative 6 over square root of 63. And the cosine of b, plugging up here, do reciprocal of this guy. 8's cancel. Become 3 square root of 3 over square root of 63. Now note here the sine is negative and the cosine is positive. So if you think of your unit circle, where the sine's negative will be in the third quadrant, and the cosine is positive here. So let's see. Okay, actually looks like the angle is going to be in the fourth quadrant because the sine's negative in the third and fourth, and cosine's positive in the first and fourth. So therefore it's going to be in the fourth quadrant, or B. So let's note that here. Okay, so the angle's in the fourth quadrant. Now, if you recall from your trig, the inverse cosine gives you an angle in the first and second quadrant, gives you an answer in first and second quadrant, and the inverse sine gives you an answer in first and fourth. Since we're in the fourth quadrant, we'll be using the inverse sine here to find our b. Okay, so let's use that inverse sine. Okay, so we're going to be using inverse sine to find our b, so we're going to take inverse sine on both sides here to solve for a b. So our b then will be inverse sine of negative 6 over square root of 63. And now, here's my answer here. The answer we're going to put in radians because we're going to be graphing this. And to graph, you need, in calculus actually, the trig functions are always assumed to be in radian measure. So the inverse sine of this guy in radians, you can check, will be negative 0.857 roughly. Okay, so I'm out of space here, so let me erase a few things and we'll keep going. Okay, so we found our b, we found our a, so plugging into our position function, so we have our a is square root of 63 over 8, to be sine then of our wt, w is 8 over square root of 3, and then plus our b was negative 0.857. So this is the amplitude then, the a. The period is found by taking the coefficient in front of the t, in this case 8 over square root of 3, dividing it by 2 pi. So doing that then, it would be square root of 3 pi over 4, so you can check it's roughly 1.36, okay? Actually, I have this written wrong. It's 2 pi divided by the coefficient in front of the t. So it'd be 2 pi divided by 8 over square root of 3. This part's still right over here. So you can check it's roughly 1.36. Okay, so now let's find our one cycle. We want to graph one cycle here. Okay. Okay, so to find one cycle, we're going to take the argument inside the sine here and put 0 on this side, so it'll be 0 less than or equal to the argument, this guy here, less than or equal to 2 pi, and I want to solve for t in the middle. Okay, and I'm going to call, instead of this period here, it's going to call a p. I'll explain why in a second, just for easy, because I'm going to refer to it later. That's for period. So let's add the 0.57 to both sides, so doing that. Okay, so adding 0.57 to the left, middle, and right, we get this. Then solving for t, multiplying by reciprocal of 8 over square root of 3, so it'll be 3 over square root of 3 over 8, which I've done here and over here. and let you check when you simplify these. This is roughly equal to 1.86 here, and this stuff over here is roughly equal to 1.55. I'm going to call the 1.886, I'm going to call it x1, and I'm going to call the 1.55 x5. I'll explain why in a second here. Okay, so the calling x1 the 0.186 and the x5 1.55 came out of space, so let me erase a few things and we'll keep going. Okay, so my x1 is 0.186, my x5 is 1.55, our period is 1.36, so we're going to be looking at a period over 4.34. So I'm going to define now x2 to be x1 plus period over 4, so it'll be 0.186 plus 0.34, which is 0.526, and x3 then to be x2 plus period over 4, and x4 to be x3 plus period over 4. So pretty much the x's are just going to be pi over 4, period over 4 spaced. So you're looking at equal spacings, where the spacing is period over 4 between each two consecutive x's. So let's compute these ones. So doing that, we get, okay, so the x3 then would be 0.526 plus 0.34, which is 0.866, and then x4 would be x3 plus period over 4. x3 is 0.866 plus 0.34, so this. And if I found x5 by adding period over 4, it should end up being this one up here. Okay, so now let's use this information to graph. So recall the graph of sine. So if you graph one period, you could choose 0, pi over 2 pi, 3 pi over 2, 2 pi. It'll go like this, the graph. So the x1 over here is going to be acting like the 0 here. The x2 is going to be acting like the pi over 2. The x3 is going to be acting like the 3 pi over, pi. The x4 is going to be acting like the 3 pi over 2. And the x5 is going to be acting like the 2 pi's. Let me write that here. Okay, so I've put my x's, x1, x2, x3, x4, x5 here. So they're all equally spaced. I guess they're equal to these guys up here, but I'm just going to write them as x1, x2, x3, x4, x5. Then I put my y-axis over here. Now, the spacing between x1 and x2 is the period over 4, so it's the 0.34. That's the spacing between x1, x2, x2, x3. All the spacing should be the same as 0.34. And notice that x1 is 0.186. So if I half that, it's almost like this one. So therefore, x1 should be fairly close to the y-axis. So pretty much that's 0.34, that distance. So half of that is going to be roughly 0.186. That's what I put here. So my y-axis should go here. And we know that x of 0 is negative 3/4. And here's my position function. We mentioned earlier that the a is roughly equal to 0.99. So let's say negative 3/4, let's say is here, say. Okay, that's at times 0, so at times 0 it's going to go through here. Okay, so now let's graph the function. Okay, so it goes through negative 0.75 on the y-axis. Then the x1, as we mentioned, is going to be acting like the 0 here, so it's at the lowest point, so it's going to be right here. Then the x2 will be acting like the pi over 2, which will be at the highest point, which will be up at our a value, which is 0.99. Then it's going to come down to the x3, which is acting like the pi, which is back down to here. Then it's going to go to the lower one, down to negative 0.99, and back up to 0 here. So that'll be one cycle. Okay. All right, so we're done with the question. So let's leave it there.